Okay, and we're going to look at high-level languages. So high-level languages are a fancy name for programming languages that we're familiar with. So you've probably used Scratch or Python, True Basic, Visual Basic, and these are languages that are understandable by humans, but they can tell a computer what to do. But actually what happens is they don't tell a computer what to do, they get turned into machine code, which as we know is the language the computer understands, and that machine code runs on the computer. And the process of going from high level language to machine code is the bit that causes all the frustration, because it only works when the high level language is completely correct and can be translated into the machine code. So that means it's made up of English keywords, and it also has a lot of built-in functions for common things that programmers would do to try and save programmers time and make it easy to program computers. So basically what you do is you start in one language, you end up in another called machine code, and there's two ways to do this, and we need to find out what they are. We can give a very simple example. Look at that sentences on the right. First thing about that is that they're in Cyrillic, so they're in fact in Russian, and we can't understand them just by looking at them. We could understand them if we understood the characters involved, but someone can understand them. If we were trying to translate from one to the other, I would either need to translate the whole thing, so send it away to someone, get them to send me it back, and then I can read it, or I would need an interpreter to sit beside me and go through them. Now, the reason why you would pick one of those approaches will entirely depend on what situation you're in. So if I was in a meeting at the United Nations and I needed somebody to tell me exactly what's been said as it's happening, I need an interpreter, because I can't wait to the end of the meeting and have a translation of what's said, because it's too late. If on the other hand I'm going to read a document, I'm probably going to use somebody that can translate the whole thing for me in one go. So if I was to do that, that's going to end up with a version that's not in Russian, it's all in English. It's going to take longer to get there, but I'm going to have a copy at the end which I can read any time, and I don't need the translator, I don't need the interpreter there with me. So thinking again, imagine you had a robot. The robot speaks Russian. The forward and backwards, clockwise turns, anti-clockwise turns, pick up and drop off. We've got given instructions for that. Let's now say we're not speaking Russian, we're speaking machine code. Notice that every instruction is given a different number, and those numbers are going to be sent to the robot. So 000001 means walk forward, 011100 means turn clockwise, etc. Some of those combinations will work, some of them won't. So walk clockwise 90 degrees doesn't work. Much like programming languages, that means we've got combinations of things that will a machine code that we can put into a program and they'll run, and other things that might cause us errors. So we'd use that translated code in zeros and ones to write out a set of instructions to get this robot to turn and go all the way to the donut. So let's presume the robot is facing straight on first. So if it rotates 90, it can walk up the way, for example. It rotates anti-clockwise 90, you could walk up the way. Can you write a program that will take him there, and then can you convert it into machine code? So the first thing I want you to do is try that by writing out all the instructions at once. So you have to write them all out first before you try it, and then we would translate them all and then give the whole translation to the robot. So if you checked your code carefully, you might still have found you had mistakes. You won't see those mistakes till you run the whole code, which means a lot of the code might never actually happen because you might have crashed the robot. And even though we can give the instructions to the robot and it can carry them all out, we can't react to any feedback. So if we've made a mistake, we can't fix that. The robot's going to follow those instructions and possibly end up in the wrong place. Let's try that again. This time I want you to look at the picture, but I want you to carry out each instruction one at a time, which means you can decide what instruction you follow as you go. So try that again, one instruction at a time. Okay, so if you did that, you probably found it was easier because you can see the result of the previous instruction and you can move on. You also probably found the robot was moving slower because each instruction you're given has to be translated and then run on the robot. It's going to take more time. So this is the two approaches to translating a program from high-level language into machine code. The first one's called interpreter, the second one's called compiler. So starting with interpreter, this happens live, so it's like a live interpreter at the United Nations. A line at a time is fed to the interpreter, it translates the line, and it runs the code and does on screen or does whatever it needs to do. There's advantage to that. It's very easy to spot errors. If something happens and it's not what you're expecting, you can react to that. You only translate a line at a time, so it starts straight away. The first line, you get the result straight away, and it runs the program immediately because of that. But the interpreter must be there the whole time. It must be running alongside your code, which means that the whole thing runs slower because each line has been translated as it happens, so the whole thing is much slower. Interpreters are really useful when you're writing code and you want feedback on each line of code, but they are slower running and they don't produce anything at the end other than the results on screen. So you don't get a copy of your program that can be handed to another computer to run because it would need to be translated again. A compiler does it differently. It takes all the code, translates it into machine code, and produces a copy of that code. Because of that, it's harder to find the errors as you go because it's going to wait till the end. It's going to report the errors to you if it doesn't work, but you're not going to end up with a copy then. And it only translates code once. So once it's been produced, the machine code copy, you've got that forever, which is a good advantage, obviously. It runs the program after the code is translated, so you have to wait till it's all translated before you can use it. And the code runs really quickly because it's already translated. It never is translated again, so it's going to operate really, really quickly. So that's basically the difference between these two approaches. An interpreter translates and executes the program one line at a time. If an error is found, it will stop and you can fix it at that point, and it must be running while the program is running, which means it's going to go slower. A compiler translates the program in one go, saves it as a fast running standalone machine code version which can be run on any computer that uses that machine code. If there's errors in the program, like errors that it still runs but it does the wrong thing, you'd need to recompile the whole program, and it's not needed to use the compiler ever again. So once you've compiled the program, you can run it. So think about a computer game or an app on your phone. You don't know what language it was written in because it's machine code copy you've got. You don't need to worry about what language it is written in. If an interpreter was being used, you would need something on your computer that was translating that as it goes. So just finishing with an example here as a terminal. This is Python. You will see these little messages come up sometimes when you open Python.